will start with the similarly we will continue with the previous topic of the finite state machine. So now we will do we also do some examples here in this lecture. We also do some more example in my next lecture. What is our objective? So our objective is to design a sequence detector. So can you see the sequence detector? Okay, so please remember we already did in the finite state machine. There were different steps. We also covered it with the finite the vending machine example. So first we give a description of the problem, then we obtain a state diagram, which is a finite state machine. What is a finite state machine? It's a graphical representation of a sequential circuit where circle represent a states and arrow represent a transition from one state to another states. So not what was the next step? We assign the binary code to the state and we draw the state transition table, and then we derive the equation, and then we finally draw the final circuit diagram. We did it in our the vending machine example. Now today we will do another problem which is called as the sequence detector. Okay, what is our objective? So this is now the block diagram of a sequence detector. If you look at the block diagram of a sequence detector, okay, what are the inputs and what are the outputs? Please quickly. So basically, I will note the name. What are the inputs and what are the output? This is a sequence detector. Anyone may answer.
X and clock.
Yes, X and clock are the inputs and output is Z. Okay. So what is a sequence detector? Okay. Now what we want to, and now in the exam I'm asked for a sequence detector that can detect. Okay. So this is our objective. So detect a sequence. So we want to design a sequence. So what is our objective? So plus we need to have the objective specification. So what is my specification? So the specification is that we want to design a sequence detector that detects a sequence of 111. So they detect three consecutive ones. They detect three consecutive ones. And I'll explain this one in an example. So now can you see here? Okay, so now please remember. So now this is actually okay. Now in this example, what is our input? So basically, please look at here. If you look at here, this x, what is my x now? So this is x is my input. So what we are going to do? So this is x is my input. This x is my input. And what is my output? Can anyone tell me? Anyone, please, quick. I want quick answer. Yes. So basic
Z.
Z is my output. Okay. And now when we want to have, so basically to detect a sequence of 111. Okay. Now please remember in this case now we need to know the notion of the clock. So basically what we do in any sequential circuit, please remember this is very important. In any sequential circuit we need to know the notion of the clock. So we have a clock here. Now we have a clock here. And let's assume we are working in a flip-flop and we have the rising edge of the clock. And the system will change the state at the active edge of the clock. Let's assume the active edge of the clock is the rising edge of the clock. So this is actually called as T0. This is called as T1. This is called as T2. This is called as T3. This is called as T4. And then it's T5 and this is T6. Okay, so for any sequential system, now please remember for any sequential system, this is very important. So for any sequential system, and this sequential system, okay, now please remember, it can be a vending machine, as we did in our last lecture, or it can be a sequence detector. Sequence detector is another example of, and we are doing it now. For any sequential system, the state will change. The state will change at the active edge of the clock. Active edge, and in this case, the active edge is the rising edge. Please remember. So we are working at rising edge of the clock. Any question? This is clear or not clear? So in any sequential system, the state will change at the edge of the clock. Any question? This should we proceed or not? Okay, now I'll explain this with an example of sequence detector. Please remember, if you look at the sequence detector example, so what is my input? Okay, and then we have some, can you see here? So now we have the, so please remember, so let's assume the system will change at the active edge of the clock. Okay, now what we are going to do, so control A, so I'm copying it and paste it as a, And now what I'm going to do, so now I'm going to copy this sequence detector, Control C, and I'm pasting it here. So now this is my sequence detector. So now let's assume a scenario. So let's assume we have X now. My input is X. And then we need to know the notion of time. Please remember, and this time is actually the active edge of the clock. So let's the first time is t0, then it is t1, then it is t2, then it is t3, this is t4, then this is t5, and this is t6, then this is t7, this is t8, this is t9, and this is t10, and blah blah blah. And please remember, the time continues in time. This can be t11, t12, and goes on infinitely until infinite. But let's assume we have some values for x. Let's assume the value of x is 0, 0, 1, 1, 1, 1, 0, 1, 0, 1, 1, 1. So can you see the sequence? When there is, because what is our objective? Please remember, our objective is, this is a sequence detector. That detects, please remember your objective. So that detects a sequence of three consecutive one, one, one. Okay. Can you even tell me when we have three consecutive ones? At which time we have three consecutive one? Please, if anyone will answer, make it some points.
T2, T3, and T4.
Yeah. What?
And T8, T9,
T2,
T10.
T3 and T4. So basically, can you see here? This sequence is detected here. Got it or not got it? So basically, the sequence is detected time T4. It's important because the sequence is now detected time T4. And then the same sequence is detected at time which time? Time T10. So this sequence detected here. So for this case, now we have the output Z. So now this output Z is actually the purple color. So now it is 0, 0, 0, 0. And now we have three consecutive one, output is 1. Then 0, 0, 0, 0, 0, and then 3 is correct. Any question? This is clear or not clear? Clear or not clear?
Clear.
Okay, now take another example. Take another example. Okay. So let's assume we have the same thing. So let's assume we say now we have another example. And please, I need your attention here. Anyone who will answer may get some points. So please, this is important. So let's assume we have another example. So we have, let's assume X. And now we have different time instances. So this is T0, T1, T0, and these are different time instances. So this is actually T0, then we have T1, then we have T2, and blah, blah, blah. I'm not just noting the time now because you know it. These are different time instances. And these time instances are the active edge of the clock. So let's assume the thing is 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, 1. So this is T3, T4, T5, T6, T7, T8, T9, and T10. Can you tell me? Okay, now please remember, here we have a sequence of two ones, not three ones. Please remember, we have two ones. Will output will be one? No. When output should be one? At which time the output should be one? Anyone may answer.
Will it be T7 and T8?
Very good, Sidra. Very good. I'm now noting your name. Very good, Sidra. Sidra. So it's your sixth answer. Very good. Thank you for your answer. So it means that you're attentively, attending, and I really like it. Thank you very much. So can you see here? So we have a T7. So Z will be one, and then we again have another sequence of. Can you see here? We have another sequence of this. Can you see? Also, we have this consecutive one. We have three ones here. One, 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 and this output is one. Any question? This is clear or not clear? So for all other things, Z will be 0. Any question? Any question? Clear or not clear?
Yeah, Professor, I don't understand. Can you repeat?
What's your good name?
Nuruddin.
Nuruddin. Nuruddin, because we want how many consecutive ones? How many consecutive ones do we want? Three ones or two ones?
Three.
Three. So should my output be one here? No. I want three consecutive ones. Now we have three consecutive ones. One, one, one. The output is one. Got it or not got it?
Yes.
But if I'm going from T8 and I'm going backward, so I got three consecutive one, then our output is one. This got it or not got it?
Yeah, okay, thank you.
This clear or not clear? If not clear, I will explain it more.
Yeah, clear.
Clear. Okay, now we have the problem now. We have the problem now. But we want to solve this using a finite state machine. And in finite state machine, we need some circles. We need some circles. We need some arrows. So we need some circle. Remember, we also did it in our vending machine example. So we need some circle, we need some arrows. And how we do it? So we proceed further. How do I proceed further? So basically what we can do, so basically what I'm going to do, I'm now going to copy and paste. So basically what I'm going, this is my sequence detector, control C, and then I'm going to paste it here. And wait, please look at it, this. And for this thingy, the most important thing is now basically we have the state. Okay, now we define some state. So now how will I solve this problem? We define some state. So it means basically what I'm going to define some states. I'm can say, okay, so I'm define some state. S0 means the input is 0. The first input is 0. S1 means we got the first one. The first one. And then we say, oh, S2 means how many ones do we get? We got how many ones? Help me.
2.
2 ones. And S3 means
It's invalid, right?
we got how many ones?
3.
3 ones. So should there be a state S4? Should there be a state? I'm asking a question. Should there be a state S4? Do we need it?
No,
No. Why?
because it's only 3 ones we need to
Because we
detect.
want to detect 3 ones. If you want to detect 4 ones, then we need S4. You got it or not got it? Clear? So since we need 3 ones, so we do not need S4. So now what we are going to do? Now we are going to solve this problem, and we are going to solve this problem by having some. So basically, now what we are going. So basically, what we are going to do. So now we have some set S0. We are in S0 currently, and basically what we are going to do. So basically, then we need a reset mechanism, and this reset mechanism will initialize the system to some known state, which is actually S0. Any question? Got it or not got it? Clear?
Clear, Professor.
Okay, now the thing is, so now we are going to do, so now what I'm going to do, so I'm now going to copy and paste as you do it in your exam sometime from ChatGPT. Okay, so now what we are going to do, so basically this is the reset, and now let's assume I'm in state S0. Okay, so there are two possible, so now the input is X now, this input is X now. What are the possible value of X? X can be what? S can be either 0 or 1. So we need to see. Let's assume if I'm in state S0, now I'm in state S0, and X is 0. Where should I go?
Stay in
S1 or
S0.
huh? Yes,
Stay
very
in
good. What's your good name?
Nuruddin.
Very good, Nuruddin. Nuruddin got me an answer, so it is your fourth answer. Very good. So it means that if it is 0, it will stay in as 0. And if it is 1, where should it go?
S1.
S1. It means it. Oh, now we got the first one. So we got S1. It means S1 means we have received the first one. Any question? Okay. Now what I'm going to do? Yes. Any question?
No, Professor.
Now let's see. I'm now in S1. Now I'm in S1, and now I'm using the green color. Please, I'm using green color. There are two possibilities for the value of X. X is 0 or X is 1. When X is 0, where should I go?
S0.
Yes, it means that I go back to S0 because now the sequence is now broken. So I go to X is 0. And let's assume if X is 1, where should I go?
S2, because that's the consecutive second one.
Yes, what is your good name?
Ahmed.
Ahmed. Full name, Ahmed.
Ahmed Hamad.
Ahmed Hamad, your name was not there. You're answering me and was not there. Why? You're so intelligent.
Thank you, Professor.
So now I'm now noting your name. Okay, so I have noted your name. This is your first response. Very good, Ahmed. I want now more contribution from you. Okay.
Sure.
Thank you. Okay, now I'm in status 2. Assume that I'm in status 2. Ahmed Hamad, can you help me?
Yes.
If the input is 0, where should I go?
You'll stay on S0 as long as the input is 0, supposedly.
No, you will not stand. I'm in S2 now. I will not stand S2.
No, if you're in S2 and the input is 0, you're supposed to stay in S0. You go back to S0.
No, you not stay at S2. You go back to S0.
Yes, you go back to S0, yeah.
Yeah, you guys, this is the use of some English. So you need to, S0. I go back to S0. And listen, if it's 1, where should I go?
You go to S3 now.
Right, okay, we go to S3. And means we have received the third one. Got it or not got it? Any question?
Yes.
Clear or not clear? Now let's assume I'm in status 3. Definitely there are also two possibilities of X. It can be either 0 or it can be 1. If it's 0, where should I go?
You go back to S0.
Very good. So if it's 0, it goes back to S0. And if it's 1,
You have to stay in S3 because S4 is not needed, as you stated.
yeah.
before.
Very good. Very good. Very good, Ahmed Ahmad. Very good. Thank you. Thank you for your.
No.
So now at this point of time, okay. Now, if you look at here, how many states are there total?
4, supposedly. S0, S1,
There's
S2,
four.
and
S0, S1, S2, and S3. Got it or not got it? Any question? Clear or not clear? So in the exam, I may ask for a sequence detector of that detects 4 ones. I may ask for a sequence detector that detects 5 ones. So there can be a lot of questions. Got it or not got it? Any question? Should we proceed?
yes, Professor.
Okay, very good. So what we are going to do, so now what we are going to do, so now this is how we did it. Now we say we draw the state diagram and everything. And now what we are going to do, okay, now please remember, there are two type of FSMs. Please remember and remember. So, okay, now there are two type of FSM. Please remember, we are going to now sequence detector using two methods. One is called as the Moore FSM and other is called as Mealy FSM. And please remember that FSM that we draw, it is actually the Moore FSM. We will also solve the same problem using Mealy FSM. But now, now the question arises, what is the difference between Mealy and Moore FSM? Anyone who will answer this question will get some points. Anyone? Yes? So there is no
In
response.
the
Oh, yes?
output
Yes?
depends on the current state,
Uh-huh.
and really output depends on current state and input.
Very good. Kaiser, you're very good. Very good. Kaisers. Your name is not there. Kaiser, why your name is not there? I'm surprised your name is not there.
No, it was there. I answered.
Huh?
I answered previously.
You answered previously? Ah, yeah. Your name was there. Yeah, Kaiser is there. Yeah. Sorry. Kaiser, it is your second response. Yes, you answered previously. Yeah, it is your second response. Yes, I got it. So, what is the difference between the Mealy and Moore FSM? I will explain this in an example. Assume that we have two FSM. Please remember, please remember, I just an arbitrary FSM. Let's assume this is my FSM one, and these are any state, arbitrary state. So let's assume if you say 00101, 01101, 11000. Let's assume this is an FSM one, which is red FSM. Okay, now we have the blue FSM now. Okay, now please remember, if you look at the red FSM, please remember, this is also an FSM, this is also an FSM, but there is a difference between these two FSM. In the red FSM, the red FSM is called as the Mealy FSM. Why it is Mealy, I will explain it. In the Mealy FSM, so we have an edge. On the left hand side of the edge, we have some inputs. So these are inputs. And on the right hand side are the outputs. Got it or not got it? So basically, I will use different colors for the inputs. For the inputs, I'm using the green color. So these are the inputs. These are the inputs. And on the right hand side are the outputs. So I'm now using a black color for the outputs. So these are the outputs. So in this Mealy FSM, how many inputs are there? In this red one, so in the red one, so if we go for the red one, there are two inputs. And how many outputs? Three outputs. And in the Moore FSM, if you look at the Moore FSM, please remember, so the input is in the green colors. How many inputs are here in this case? How many inputs are there? And the output is inside the state. So the output is inside the state. So can you see here, there are three outputs here. And output is inside the state. You got it or not got it? Any question? Is clear or not clear? Any question?
Professor, why?
Professor,
Mm-hmm.
how is it two inputs for the red one? It's three.
No, there are two inputs. Input is on the left side. There is a slash here. On the left hand side of the slash and the arrow, these are the inputs, and the right side, these are the outputs. You got it or not got it? Okay, now what I'm going to do, I'm giving you another example. I'm giving you another example, and then you'll be you know, with this example you'll understood what's going on. Again, we have another FSM. So I'm now drawing two FSM. Please remember, this is FSM1, and this is any arbitrary FSM. These two, and just arbitrary FSM. And now I'm saying 0 1 0 1 1 1 0, and this is one edge. So this is 0 0 0 and 0 and 1 0 1. This is FSM1, and we have FSM2. And let's assume this is 1 0 1 and 0 0, 0 0 0 and 0 1, and blah blah blah. So if you look at this FSM, the left SM, it's a Mealy or Murray, the left one. How many inputs? Help me.
2.
No. Can you count? It's true. 0 1 0 1 is 2 inputs.
1.
3 inputs.
No. 4 inputs.
Oh, based on okay.
If based on the number of bits. You got it or not got it?
Yes.
Okay. Now on the right hand side, how many outputs?
3.
3 outputs. You got it or not got it? Mealy or
Yes.
Murray? Mealy.
Mealy.
And this one is Murray. How many inputs here?
3.
3. Now you got it. What's your good name?
Abir.
3 inputs. And how many outputs?
3.
No.
2.
Because what I'm going to do, basically the thing is, so yes, 3 inputs and 2 outputs. And output is inside the set. Any question?
Okay.
Got it?
Yes.
Okay, now we are doing it with the Moore FSM. Please remember, this is a Moore FSM. Okay, now can you see here now? So now what I'm going to do, so I'm now going to do it like this. So basically what I'm going to do, yeah, it's good. Okay. Now what we did, please remember this, we did this state diagram. You got it? We did this state diagram. Got it? This one. Is this clear or not clear? This is clear or not clear?
Clear, Professor.
Okay, now what should we do now? Can you tell me what should we do now? After doing this step, what should we do? Can you tell me what should we do? After this step, what should we do? Because we did it in also the thing. What should we do?
We should do the truth table.
Yes, state transition table. Very good. Not a truth table. We call this a state transition table. So in the next step, we should do the state transition table. And for the state transition table, the most important thing is to do this thing. So we do the state transition table. Okay. Now what I'm going to do, I'm going to explain it. No problem. So basically what I'm going to do, so there is also some good animation, and you can also go to the presentation, and in the presentation you'll like. So basically, can you see here? This one is the thing. So let's assume we are in a state 0 0, we go state is at 0, we receive the first one, we go to S1. We are in S1, we get another one, we go to S2, the second one. Then we detect the third one, we go to S3. Okay, so now complete the state diagram. 0 you go to S2, 1 you go to S1, 0 you go back to 0. Got it or not got it? Clear or not clear? So this is the first one, the second one, and the third one, and you go to S3. And in S3, can you see here in S3 the value of Z is 1. So basically the output is inside the state. So basically, can you see here, now we have the output Z. So this is my input X. So this is actually, please remember, this is very important. This is X. X is 0. Here, what is this? X is 1. So these are X is your what? X is your input. And what is my output? My output here is Z. So my output is Z. Z is my output. Got it? And since Z is my output, so what I'm going to do, I'm now using another color. So now I'm using a color of black. So Z is my output, and output is inside the state. So here Z is 0, Is it clear or not clear?
We cannot
Yes,
see
student.
the screen.
Man, the problem is with the pen. Sometimes I'm very surprised with this pen. Sometimes the pens. That's the reason I don't like the online thingy. Sometimes you lost everything. Okay, this clear or not clear? Screen is visible to you?
Yes.
Yes.
Okay, so basically, can you see here? So this is x. X is 0. X is 1 here. So x is and z is inside the state. Got it or not got it? Clear or not clear? And z will be 1 when the system is in state S3. Got it or not got it? Because we have got. So we received the first one here. Then we get the second one. Then we get the third one. When we reaches to S3, it means that now z should be 1. Clear or not clear? Please answer
Clear.
me.
Clear.
Okay.
Professor, when it's in S3 and it receives 1, will it stay in S3?
Yeah, it will stay in S3. Yes. Because then let's assume if we have 1, 1, 1, 1. So we should go for the last 3 ones. We should go for the last 3 ones. Got it or not got it?
Oh, yeah, okay, thank you.
Okay, so can you
Professor,
see here
what do
now?
you mean by the output is inside the state?
Yeah, the output is inside the state. Yes, the output is inside. Very good. Very good. The
What,
output is
what,
inside.
what does that mean?
So it means that the output is inside the state. I will explain it. What's your good name?
Zafar.
Zafar. I will. Can you give me some time, like 1 minute? I will explain it.
Okay, Professor. Thank you.
Okay. Now, please remember what is my next step. So we need to draw the state transition table now. And please remember, this is now a Moore FSM. Please remember, this is a Moore FSM now, not a Mealy FSM. In the Mealy FSM, we have XT here, but here we don't have XT here. And I'll explain it. Okay, please remember there are some colors. What does red color tells us? What does red color tells us? Can you tell me what does red color tells us?
The input.
No, red color. Please look at here. Red is input. Red is the current state. Okay, what does the blue color tells us? The input. Please remember it is also the previous thing. And now we have the next state. The next state which color? So we have what is this? This is actually ST plus 1. And then we have some output YT, which is the purple color. And Zafar, please stay tuned. I will answer your question now. Got it? Okay. Now, how many possible states are there in the state machine? So we have 4 states. Please remember we have now 4 states. So we have 4 states. So we have S0, S0, then S1 and S1, then S2 and S2, then S3 and S3. Okay. Now the input, if you look at the input X, the input is 0 or 1, 0 or 1, 0 or 1, 0 or 1. Got it or not got it? And what is my ST? My current state is S0. I receive a 0. Where should I go back? Anyone may answer.
Stay in 0.
Stay 0.
Yes.
I receive a 1, I go to S1. 0, I go to S2. 1, if it's 1, sorry, I go to S0 now.
Yes, and then you go to S2.
Then you go to S2. S2, 0, I go back to S0. S2, 1, I go to S3. S3, 0, I go to S0. And if it's 1, I go to stay in S. Got it or not got it? They clear or not clear?
Yes. Yes, Professor.
Okay, now please remember, the output, please remember, the output is now inside the state. So this inside the state, Zafar, I'm now answering you. So this output Z is YT is 0 inside the state. So basically in state is 0. So YT, which is actually my Z now, this is my Z. This is my Z now. Okay, so this is YT should be now, I'm now using this purple color. It should be 0, 0, 0, 0, and 0, 0. And since it is S3, it is 1, 1. Got it or not got it? This is clear or not clear?
Professor, so
Yes,
how is
Zafar.
it if it's outside the state?
If it's outside the set, then there is a Mealy FSM, and we will study this Mealy FSM in my after somehow. You got it or not got it? We have solved this problem using Moore FSM. If it's outside the state, so there is a Mealy FSM, and with the Mealy FSM, the problem becomes different. You got it, Zafar?
Yes, Professor.
Okay. Now what we are going to do? What's my
Professor,
next step? Yes, please go ahead.
won't the last 3 be 1, 0, 1?
Which one?
The last 3 outputs?
Mm-hmm.
It'll be 1, 0, and then 1
No,
because
no, no,
it's
no.
in S3.
No. So basically, if you are in S3, if you are in S3, okay. Now please remember, all of you are now. Please remember now. You have got it. Siddharth, this is a big problem. Now I'll explain it. Let's assume I'm going for this example. We did this example. Got it or not got it? Now I'm going to tell me the states that we have. So let's assume we 0. I will stay in S0. 1. I go to S1. T2. I go to S2. Okay. Since 0, I go back to S0 now. You didn't get my point, Sidra. Got it or not got it?
Got it.
Then we have 1, I go to S1, S2, I go to S2, in T6, I go to S3, and then output is 1. And because in S3, output is 1. Got it or not got it?
So when like after S2 we get a 1, then it won't be 1 like the output.
So now, when we go to S2, the output is 1. So the output will be 1 in state S3 at time T6. Again, now I'm in S3. I receive a 0. I go to S0. Then S0. I go to S1. Then go to S2. Then go to S3. And now output is 1. Sidra, you got it or not got it?
Got it, Professor.
Okay, now let's say here now let's say this state. So let's assume this is S0, then S0. I go to S1, this go to S2, then go to S3. Output is 1. I'm in S3 and I got S1. I go to S3 and this is still 1. And then S0, 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 S1, S2, and blah blah. And then you got it or not got it?
Got it. Yeah.
Any
Thank
question?
you. No. Thank you.
I hope I answered your question now.
Yeah.
So because this is all done with the example, so that's a good thing that the question will come into your mind. So basically, can you see, now we have done this thingy. We have this. Okay, now we need to assign some code to the state. Let's assume what should be the code for S0. Anyone may answer. Yes. Zero 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 one zero one 10 10 11 and 11. So this is code assignment. What is S0? 00. Then what? 01 00 10 00 11 00 and 1. Any question? Clear or not clear?
Clear, Professor.
Okay. Now what do you do? I'm copying and pasting it here. Okay, now it is so now can we see here? Now please remember, this is very important now. This is very important thing. What I'm going to do, so I'm going to make it like a little bit, this is the state transition table. Got Control X. This is first thing that we got it. Please remember, this is my diagram now. This is my diagram now. And please remember, for this important thing, so the state transition table. Okay, now please remember, whenever we have this diagram, so please remember, this is very important for you to know. So we have, now we what we do, so we make some diagram. This is my state memory, SM state for state memory. This is my output logic, which is OL. And this is my next state logic. I call this as NSL. Okay, please remember, this is XT. So this is XT, and XT is my actually input. So this is my X now. X now. Okay, now the output of this state is ST plus 1. So ST plus 1 is actually the next state, and basically this is the input. So basically we have two flip-flops. So DC flip, so we call this as D1 and then D0. Please look at the color coding. ST plus 1 is my next state, and then we have Q1 and Q0. So Q1 and Q0 is your current state, and basically this is the output of flip-flop. So I call this as Q1 and Q0. And then we have an output logic. And in output logic, this is YT, and YT is now my Z in this example. Okay, now we have Q1 and Q0. This current state will feed back. Please remember, this is the Moore FSM, not Mire. In Mire, it's a different case. So this Q1 and Q0, which is actually the current state, will be feedback to the next state logic. So this is feedback here. Q1 will come here, and Q0 will come here. Clear or not clear? This is clear or not clear? Any question? Yes? I'm not hearing any response. This is not a good sign. No one is answering me. Do you hear me?
Clear.
Professor, can you explain it again?
So why did you say no? Why you are wasting the time? Because I don't have any much time. Basically, please remember this. Remember this ST plus one is the input to the flip flop. This state memory is a flip flop. So these are input to the flip flop, and the input to the flip flop is always D, and the output of the flip flop is always Q. So the current state is the output of the flip flop, and the next state depends on the current state and the input. You got it or not got it? And we already did it in my FSM example. Any question? You got it or not got it?
Got it, Professor.
Okay, please remember this is state memory, and this state memory is a flip flop. When this state memory is a flip flop, so the input of the flip flop is D and the output is Q. So basically, you need to remember and memorize this diagram. You need to memorize this diagram. If you are not memorizing this diagram, you will not be able to solve any FSM based questions. Got it or not got it? Okay, now if you look at here, now please remember ST. ST is which color? ST is now the red color. So can I write something like this? So now I'm doing the red color, and this is my ST. So this is actually Q1 and Q0. And then XT, and XT is my blue color, which is my X. Then we have ST plus 1, and ST plus 1 is D1 and D0, which is which color? Help me. Anyone may answer. And then we have YT, which is my Z. Any question? Okay, now please remember this Q1 and Q0, and now I'm going to draw the red color. So basically, this is actually 0, 0, 0, 0, this is X0, then 0, 1, 0, which is S1, then 1, 0, and 1, 0, which is S2, and 1, 1, and 1, 1, which is actually S3. What I'm doing copying and paste as you do it in the chat GPT. Okay, so now what you do, so basically what I'm going to do, so basically I'm now using it here. So X is now 0, 1, 0, 1, 0, 1, 0, 1. Okay, now the next state is 0, 0. So basically I'm now using the green color, and the green color is actually 0, 0. This is 0, 0, 0, 1, S1, this is S1, then S0, 0, 0, then S2, 1, 0, then S0, 0, 0, then S3, 1, 1, then S0, 0, 0, and S3, 1, 1. Got it or not got it? And my YT, can you see here my YT is actually, we already did 0, 0, 0, 0, 0, 0, 1, 1. Any question? Is clear or not clear? Clear?
Clear.
Okay, now please look at it. Now look at the diagram. So now let's assume, can I say, so from here, now please look at here. Now from the diagram, what I'm going to draw. So from the diagram, I can say, okay, now ST plus 1. Please look at this diagram. Please look at this diagram. ST plus 1 is a function of, and look at the color coding that I'm using, is a function of ST and comma and XT. So we can see ST plus 1. So please remember this D1 is a function of ST, and ST was Q1 and Q0, which is actually the red color. Q1 and Q0, and XT, which is your X now. So okay, now can I write something like, so D1, I'm not now using the not the color coding because it's written. So what is D1? D1 is what is sigma M. Can I write what is D1? This is actually 0, 1, 2, 3, 4, 5, 6, and 7. What is D1 now? Can you tell me? So D1, I'm now looking at D1. So this is actually 0, 1, 2, 3, 3, 4, 5. And then what? What about D0? Can you tell me the D0? Help me. Anyone will answer, may get some points.
1,
Mm-hmm.
5,
Mm-hmm.
and 7.
What's your good name?
Abir.
Abir, yeah. Very good. Clear? And then we solve for D1 and D0, and then we have the next set logic and output logic. Clear or not clear? So what I'm going to do, I'm going to copy this and paste this as you do it in your chat GPT. Now I'm going to rub this off. Yeah, this is not needed. This is actually, can you see here? So now I can also rub this off, and then what I'm going to do, I can do it here. I can put it here. Now I'm solving for D1. So D1 is now signal. So basically what we have. So now D1 now depends on what? D1 now depends on Q1, Q0, and X. So please remember, this is 0, 1, 3, 2, 4, 5, 7, 6. This is 0, 1, 0, 0, 0, 1, 1, 1, and 1, 0. So basically 3, 5, 7. Where is 3, 5, 7? So 3, 5, 7. So 3 is here, 5 is here, and 7 is here. And if we solve this thingy, what will be the expression for is this? And this is just like chem map. I'm not going to explain it because this is actually, so this is what, this is D1 is actually what? Q1 x plus, and the red one Q0x. Am I right or not? Any question? And similarly, you can solve for D0. Is clear or not clear? Clear? So now when we does this thingy, so please look at, I have now solved it here. So this is the state diagram. We draw the state diagram. We got all these things. We got this next thing, the output logic. So can you see here? This is the same diagram that we did. Q1 and Q0 and X, and this is D1 and D0. So can you see here? This we solve it for this one, and this one, and this one. So Q1X and plus Q0X. And then we solve for D0. We also solve, how many ones are there? 1, 2, and 3. We solve for it. So D10 is here. And then we solve for the output. Please remember, what is my output? Can anyone tell me what will be my output? Anyone based on this diagram? I don't know where did I solve it. What will my Z? Can you tell me what is my Z now? What should be the expression for Z? Yes. What is
Q1,
the expression?
Q0.
Yes, Q1, Q0. The Z will be Q1 and Q0. And I will explain it. Okay, please remember, we solved it using K-map. And what we did, so now what I'm going to do, I'm going to copy this and paste it here. What I'm going to do, I'm going to rub this everything off. This, because you know this is not needed. This is also not needed. So we got the expression for D1. So D1 is actually Q1x plus Q0x. We also got the expression for D0. So what is D0? And please remember, we also got the expression for Z. And Z, I can directly go get it from here. So Z is here. So Z is what? Z will be 1 when Q1. So Z will be Q1 and Q0. And similarly, we got expression for D0. And if you go for the expression for D0, what is the expression for D0? Because it's already solved in the lecture slide. So D0 is... I can solve it. I could copy it from here and paste it here. So this is actually D0 is Q1x plus Q0 bar x. Q1x plus Q0 bar x. So Q1x plus Q0 bar x. Here is the slide. I don't know. Sometimes there's a lot of stuff going on, and sometimes I don't understand where, you know. Q1x plus Q0 bar x. Got it or not got it? So these are the expressions that we got it. Okay, please remember, we have now 3 logics, the NSL logic. So please remember, now what we are going to do, draw the NSL logic. What are the input to the NSL logic? Can anyone tell me? Anyone? NSL logic. The input to the NSL logic, X, yes. So the input is X. Please remember, now input is now X. What is the input? Q1 and Q0, which is the red color. Q1 and Q0. And what is the output of this NSL logic? D1 and D0. And this is the output of the 0. This will go to a flip-flop. So this will go to a flip-flop. So it will be a D flip-flop, and then we have a clock, and then we have a reset. And the output of this flip-flop, is Q now. Please remember, this Q1 and Q0. So the output of this flip-flop is Q1, because this is D1. Then we have another flip-flop. So this is another flip-flop. D0 will go here to D input. Now we have the Q1. So this output will be what? Q0. This output will be Q0 now. Then we have clock, and then we have reset. And then Q1 and Q0 will go to the output logic. Please remember, this is my output logic. So this is my output logic. This is OL, the output logic. And the output logic, can you see? Z depends on Q1 and Q0, and we found the expression for Z. So this is actually Q1 and Q0, and this will give me Z. And Z is actually the purple color. Now I want to find the expression for here in the, so what is D1 here? So now D1 is the complete diagram. It is actually Q1x. So basically what we are going to do, so we are going to do Q1, and then x. X is here. Where is x? So x will go here. Q1x plus, then again we have Q0x. So Q0 will come here. And x will come here. And then we have an OR gate. And this OR gate will go here. And then please remember, this one is this expression is Q1x. So this one is expression Q1. Q1x is also used here. So this Q1x we need to OR this with another thing. So this is Q1x, and we need another AND gate. So basically, so this is Q1x and plus Q0 bar x. So basically, then we can see here. So we have x here. X will come here, and then Q0 bar. So Q0 bar, there is an inverter for here, and then we go to here, and this will go to this. So this is the complete diagram of the sequence detector. Any question? You got it or not got it? This clear or not clear?
Clear,
Clear?
Professor.
Okay, so what we need to do, so first we go for the problem specification, then we draw the state diagram, then we do the state assignment, then we do the state transition table, then we do the logic minimization using chem maps, and based on their logic minimization, we derive the expression for the next state, which is actually D1 and D0. And when we derive the expression for D1, so we draw the state diagram. This is all the steps for sequence detector. And please remember, go through practice. This is a very complex topic, so please go through the practice for the final. If you have any question, I can arrange some help session for you, no problem. Got it or not got it? So basically what we do, so this is all the diagram. So we got it here. We already got it here. So we solved it here.
Professor,
Yes, please go ahead.
how will you ask this in the exam?
So in the exam, I may ask you, write expression for D1 and D0. So you can, in the exam, I will ask this expression. You have to write this equation, but you have to derive it. And then you can say, oh, you have to derive it. D1 is equal to Q1x plus Q0x. Then you can say, okay, you can write the expression in the soft form. So D1 is actually a function of Q1 and Q0 and x. It is actually 357. You got it or not got it?
Okay.
So you do not need to draw. And basically it's the same thing. So whenever I see, if you have some logical gates or something, so you have to write an expression, and you have to write the expression in your thing. And in the next exam, what I will do, if you solve any question, so you have to put a video of yours. So whenever you have your camera, so you have to put the working on your paper as well. So this time I have new rules now. I will tell these rules later on, that what will be the rules for the new exam. Okay, any question? Should we proceed? Should we proceed?
Yes.
Yes, Professor.
And if you say draw the state transition table, so you have to draw it. So you have to draw this table in the, maybe I will give you an FSM. I will give you an FSM. I say, oh, draw the state transition table. I may give you any FSM, and you have to draw the state transition table. So there will be a lot of practice question I post, and if you have some question, please let me know. Okay, now what I'm going to do, so basically this is state transition table, blah, blah, blah. We did it. Okay, now please remember, we have solved this sequence detector example using Mealy machine or Murray machine. Now, anyone, please quick. We have solved this example using Murray machine. Now we will solve it using Mealy machine. So this is the final thingy. So this is for the final thing. So we got the expression for this. We solved for D1 and D0, and then you can see here. Okay, please remember, this is my next state logic, and this is my output logic. Okay, now please remember, in the previous example, we solved this problem using Murray method. Now we are going to solve this problem using Mealy method, the same sequence detector example, but now the circuit will be different. I will explain this. So the same example, we have the input X, now we have the clock, and the output is Z. Okay. Again, now we need to define. Please remember in the Mealy, so now we can say Mealy sequence detector. So assume we have this state S0. Okay, reset will initialize the system to some known state. So reset, we will go to this S0. And please remember, in the Mealy machine, we have an edge. Remember in the Mealy machine, so there is a difference between the Mealy. On the left hand side is the input, and our right hand side is the output. So the input is now X and output is now my Z. You got it or not got it? Any question? Is it clear or not clear? I'm not hearing any
Clear,
response.
clear,
Okay,
Professor.
now let's assume I minus 0. In I minus 0. So it means that I minus 0 and 0 slash 0. Where should I go? 0 slash 0. Anyone may answer?
0.
Yes. So 0 slash 0. I go to S0. If the input is 0, where should I go? If the input is 1, where should I go?
S1.
S1. What should I write on this edge? Can you tell me?
0/1.
No. The input is on the left hand side, please. If the input is 1, the output is 0. You got it or not got it? Clear or not clear?
Won't it be 1/1 then? Input is
No.
1 and then output will.
Because
Oh,
we want to detect
yeah,
three
yeah.
consecutive ones. So we want to detect
Correct.
3 consecutive ones. Is it the first one or second one or third one?
First one.
It's the first one.
Yeah.
Okay. Now I minus 1. And I'm now using a green color. I minus 1. The input is 0. Where should I go? The input is 0. The output should be 0. I go back to S0. You got it or not got it? If the input is 1, where should I go? Please, quick, quick, quick. I don't have any time.
S2.
I go to S2. And what should be on the edge? Can you tell me what should be on the edge?
1 0.
1 slash 0. Not 1 0, 1 slash 0. Now I minus 2. And the input is 0. Where should I go?
S0.
So what should be on the edge? Can you tell me? Please go ahead.
0/0.
Yes. And if the input is 1, where should I go?
S3.
No. That's a trick here. If the input is 0, I stays in S2. 1. So in the input is 1, I stay in S3 and output is 1. Because S3 will be a redundant state here. I will explain this with an example. Okay, let's assume I am here in S0 and the input is 1. This is the first one. Then this is the second one. And then there is a third one. When the third one is received, output is 1. You got it or not got it?
Got it, Professor.
This is how it works. Because in the Moore machine, this output was inside the state. So basically we had to wait for one extra cycle. But in Melee, because the output is on the part of the edge, so that's the reason it will reduce the state by 1. Any question? Clear or not clear? And please remember,
Yes.
in the Melee sequence detector, the input is on the left hand side. Please remember, this is a Moore this is a Moore sequence now. Can you see here? This is a Moore sequence now. We draw the Moore sequence. Okay, so the Moore sequence is actually this is a Moore sequence now. The output is not on the edge. Output is inside the state. Got it or not got it? Any question? Clear? Yes, students. Clear or not clear?
Clear.
Clear, Professor.
Okay, good. Where were we now? So we got it here. So we finished here. So we okay. The input is on that thing. Got it? So this is for the next step. What is my next step? Okay, please remember this is the Mealy FSM now. What should be my next step now? We draw this diagram. Either draw this diagram. So this basically we draw this diagram. Okay, this was the diagram. What should be my next step? Anyone may answer. What should be my next step? Anyone may answer. Please help me. Draw what?
State function table.
Yes, state transition table. And I will use the same color coding as we did it last. So this is actually, can you see here? So now we need to draw the state transition table. So this, the input is actually ST. The state is ST, sorry. And the input is XT, X. Please look at the color coding. Okay, and then we have the next state ST plus 1, which is the green color. And the output is Y, which is actually the purple color. And which is actually Z now. And again, please remember, if you want to do that, this is very important now. This is very important now. If you want to do that, so we can directly solve it here. So basically, again, I'm now going to have the same thing. So we have the NSL logic. This is my NSL logic, and then we have the state memory, and then we have the output logic. So the output logic in the NSL, so the input is ST. So basically in the state memory, so we have the green color. So the green color, what we need to do for the green color, can you tell me what should I write here in the green color? What should I write here? There are two flip-flops. This is actually D1 and D0. And what should, if it is D1 and D0, what should be these two? Help me. The red one. Quick, please,
Q1,
quick.
Q0.
Very good. Q1 and Q0. And the output logic is actually Z, and the NSL is actually ST, which is actually ST. ST is actually, again, Q1 and Q0 is feedback. Q1 and Q0 will be here. And then we have the other input, which is X. And I put it here. And so please look at here. So now I'm going to draw the ST, which is actually the input. So this is actually S0, S0. We have, please remember, we have now three states, S1 and S1, and S2 and S2. And S3 is undefined state. So S3 is not there. Got it? So we are just, so basically, can you see here? So basically, if the input is, there are two possible value of the input. So this is actually 0, 1, 0, 1, 0, 1, and blah, blah. And ST plus 1. Okay, now please, this is a little tricky. So what will be my next state? So now I'm now going to the green color. In the input is 0, it goes to S0. If the input is 0, any state which the input is 0, it goes to S0. S2 is goes to S0. If it's n is 0, the next state will be S1. It will be S2, the next state will be S3. This is clear or not clear? Clear? Okay, now for the output, if you look at the output will 0 here, 0 here, 0 here, 0 here, and 0 here. And please remember, I'm now in S2 and the input is 1. I don't go to S2. I stays in S2, sorry. I stays in S2 and the output is now 1. Any question here? Clear or not clear? Clear or not clear? So this is, we have transformed this into state transition table. Clear?
Clear.
Okay, now please look at it. Now we need to do the state assignment. So what is the assignment for S0? It is 0, 0. This is 0, 1. This is, sorry, 0, 0. Sorry. I need to do the state assignment. So I can use a black color for it. So S0 is 0, 0, 0, 0. S1 is 0, 1, 0, 1. S2 is 1, 0, and 1, 0. S0 is what? 0, 0. S1, 0, 1. S0, 0, 0. S2, 1, 0. S0, 0, 0. S2, 1, 0. Any question? And we have the same thing, Okay, now what I'm going to do, so basically what we are going to do, so this is the same thing that it's already in the lecture slide. So this is the state transition table. We got it. Okay. No, 1 minute. Okay. No problem. Okay, so can you see here? This one is there. I copy this and I paste it here. Oh, sorry. Okay, now can you see here? Now you have Q1 and Q0. Then you have X. Then you have D1 and D0. And then you have Y. This is actually 0, 0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 0. Then we have 0, 1, 0, 1, 0, 1. And then we have 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, and 1, 0. And output is 0, 0, 0, 0, 0, 1. This is clear or not clear? Because what we did, this is actually now we converted into binary table. Any question? This is clear or not clear? Yes.
Clear. Yes.
Clear.
Okay. Now we have some undefined set S3. Now we have some defined state. So basically, this is an undefined state. In an undefined state, so basically, what we want to do some logic minimization. So let's assume this is an S3. So the input is XX and the output is XX. So basically, it's 1 1. So basically, it is input is X. So basically, 1 1 0 and then 1 1 1 1 and 0 1. So the input is X X. Why we put X and XX here? Why XX?
Invalid.
No, logic minimization. We want to do the logic minimization because the
It's
system will never be in S3. Got it or not got it? Any question? Clear? Okay. Now if you want to find the expression for D, so basically what I'm going to do, so now I want to find the expression for D. D1. What is D1? Can you tell me? Sigma M, anyone? So 0, 1, 2, 3, 4, 5, 6, 7. Can I write? What is the expression for D1? Can you tell me? Quick.
3, 5.
3, 5 plus sigma D.
6, 7.
7. What is your good name?
Nuruddin.
Nuruddin. Very good. What will be the expression for D0? Sigma M, help me.
It will be 1 only.
What will be the expression for Y?
5.
Clear? And then we solve this using K-map. So we solve this using K-map. When we solve it using K-map, this expression that we get from the K-map. And basically what I'm going to do, so I got this expression from here. So basically all the things are in the slides. So if we got these equations. So these are all the equations. Control C, Control C. I'm pasting it here. And please remember this figure. We already did it. Remember, we already did this figure. Sometimes it's very difficult for me to go from one place to another place, and sometimes it's very difficult because I don't have the board here. Because in boards it's very clear. So now we have please these things. And please remember, we derived the equation for D1. We derived the expression for D0. So D1 is here, D0 is here. So can you see here? So now if you go to the next state logic, what are the input to the next state logic? Can you tell me? Help me. So Q1,
Q0.
0, and X. And please, the output of this is actually, I'm not using some colors now because then I will actually, what is D1? D1 expression is here. It is actually Q1x plus Q0x. So Q1x plus Q0x. So this is actually Q1x plus Q0x. So Q0 will come here. Q0 and then X is here. What is the expression for D0? Please look at here, the D0. Q1 bar Q0 bar X. Okay, Q1 bar Q0 bar X. So basically there is also a flip-flop. So we have two flip-flops. Please remember, we have two flip-flops. This is flip-flop 1 and this is flip-flop 2. So this D1 will go here, it goes to the D, and this has Q, and then we have Q1, and then we have Q1 bar here. Please remember, in the flip flop we have two outputs, Q and Q bar. Then we have again D flip flop. So D0 will go here. This will give me Q0 and Q0 bar. So this Q0 bar will be here. So basically what will be there? So this Q0 bar is feedback here. And then Q1 bar, this will go from here, and then and Q0 bar, and then the other input is X. So X will go from here. This will go me D0. And output here is Q1 bar and Q0 bar X. So this is Q1 bar. So this is output logic. Q1 bar and Q. So this is output logic. Q1 bar and Q0 bar. So this is Q1 bar and Q0 bar. And then X. X is also the input here. X is here. So it is the end of all three. And this will give me Z. Got it or not got it? So this is the final expression that we get. So can you see here from here? Please look at here from here. There is all the explanation that's given here. This is the output logic. Any question? This is clear or not clear? Clear? Yes. Yes, students.
Clear, Professor.
Okay, so now what we need to do, so now please remember, now if I give any question in the exam, in the final, so basically, so we have two things now. This is very important. This is now what I'm going to do. I'm going to do comparative analysis for both of them. So I'm now going to do the comparative analysis for the both of them. So let's assume we have two FSM. We have a Mealy FSM, and in Mealy FSM it will look like this. We have the next state logic. Okay, then we have the state memory, and then we have the output logic, and the input to this is actually this will give me ST. This ST will be feedback here, ST, and this will give me ST plus 1, and we have a clock here, and then we have a reset here, and then we have XT, which is the input, and this XT will go here, and you have YT. This is the Mealy machine. Please remember, but in Moore FSM, which is actually now I'm going to draw with the blue color, we have NSL here, we have state memory, we have ST. ST is feedback here. We have the input XT. We have ST plus 1. And now we have an output logic. And please remember, this ST is not here from here to here. So this is missing. And this is my YT. Any question? And in Mealy FSM, if we go for the diagram, so in diagram, so we have in the Mealy FSM. So please remember, in the Mealy, this is a Mealy FSM. Remember, this is a Mealy FSM. So if we have an edge like this, 0 and 1, this is Mealy FSM. This X is the input, and this one is the output. And this is a Moore FSM. So we have the Moore FSM. So we have an edge, 0. This is the input. And the output is inside the state. Any question? Is clear or not clear?
Clear.
Clear? Okay. So now the question of, so now we do a comparative analysis. This is the Mealy FSM or Moore FSM? This one.
Mealy.
This is Mealy. And what about Moore? This one, Mealy or Moore? Yes. This is Moore. Why? Please, in Moore, so this can you see this is the difference between the Mealy and Moore FSM. This is the difference. Any question? Clear? Any question? Got it or not got it? Okay, can you see here from here? So, So we have two diagrams. We draw two diagrams here from here. I don't know where is the Mealy and Murray. I got it. This is Mealy or Murray. This one.
Melee.
Why Mealy? Why Mealy? I have thought this is a Murray FSM because on the edge we don't have input and outputs. This is the Murray FSM. You're not getting my point now. And if
No,
you look
I
at
got
here,
it, Professor. I just confused.
no, this is very important for you because in the exam, if I ask you a question, this is in fill in the blanks, and you do not, so you'll get 0 points now. Can you see here? This is Mealy or Murray. This one. This one.
Melee.
Mealy.
Yeah.
Why Mealy?
The output is in the edge.
Output is on the edge. Okay. The input is on the left hand side of the slash, and the output is on the right hand side of the slash. You got it or not got it?
Got it, Professor.
Got it? So there will be a lot of practice problem that I'll post it on here, and then and then you need to do all these practice problem. I will post this practice problem, okay? And then you can do all the practice problem, and then we can see here. So okay, so now please look at here in the Mealy machine. So now I'm going to explain it in the Mealy machine. So I'm now going to elaborate it. In the Mealy machine, the output yt is a function of the current state st and the input xt. But in a Murray machine, the output yt is a function of the current state st only. You got it or not got it? So this is the difference between the Mealy machine. So in the Murray machine, yt, so this is the Murray. So yt is a function of st only. But in a Mealy machine, the output yt is a function of the current state st and the input xt. So this is the difference between the Murray machine. And this difference is highlighted by this arrow, which is the blue arrow. Got it or not got it? Any question?
No, Professor. Got it.
Got it? So what I'm going to do, I'm now stopping the recording. Any question?